Hello everyone. For this tutorial video, I'd like to explain how to determine the arc length of a vector function. So we first see that all the inputs are arguments of a parameter t, and that the arc length is between two specific points always, which we will mark a and b. We remember we proved the formula for parametric curves in 2D is the integral from a to b of the square root of the derivative of function 1 squared plus the derivative of function 2 squared, all integrated with respect to the parameter t. It follows because we know the Pythagorean theorem can be extended to 3 dimensions, and that it is simply adding the third dimension squared into the calculation. We see logically we must add the derivative of function 3 squared to get a 3D parametric curve. We see by how vectors work. The magnitude of the tangent or derivative is simply the Pythagorean theorem of all of its components. And we remember to take a derivative or tangent, we simply take the derivative of the individual components. In conclusion, we substitute in this magnitude of the tangent and state the arc length is the integral from a to b of the magnitude of the tangent with respect to the parameter t. So now that we have a simplified formula for the arc length of a vector function, we use this as an example. The first step is to calculate the tangent, and then we next calculate the magnitude, or the square root of the sum of all of its components squared, and once we get a finite value for it, we integrate between the 2 points given, so 0 and 2 pi. And we remember the integral of a constant is the constant times x. In conclusion, 2 pi times 2 times square root of 10 is 4 pi times square root of 10. And the other part is 2 times square root of 10 times 0 is simply 0. So we have for our final answer 4 pi times square root of 10. And that is our conclusion for the exact arc length. There is actually a function that uses the arc length, oddly enough, called the arc length function, that is defined as arc length of t equals the integral from 0 to t of the magnitude of the tangent with respect to change in u, where the tangent is of u rather than t. Using the previous example, but with the arc length function rather than arc length constant, we remember the magnitude of the tangent is 2 times square root of 10, and this is always true regardless of the input. So now we integrate from 0 to t with respect to u. Because we integrate with respect to u, t is essentially a constant. So we have 2 times the square root of 10 times u, where u equals t at one point and u equals 0 at the other point. The point where it is equal to 0 is simply 0. So we see the arc length function is 2 times the square root of 10 times t. So we see we can solve for t by dividing the function by the constant you multiply t by, or the arc length. So now that we know a value for t in terms of arc length, we can plug this in for all components in the original equation, and this is called reparametrizing. Because of the fact you are changing the parameter. This may seem like a useless maneuver at first, but it is actually useful to tell where exactly we are on the curve after we have moved a distance of the arc length. And because of how the function is defined, we always start at the point t equals 0. For example, if we want to know where we are on this curve, after traveling a specific distance of pi times square root of 10 all over 3, we see, because this is the same example we worked with earlier, we know what the new parameter is, so we substitute this in. See that we are given explicitly what the arc length s is in the problem, so we substitute this in, and after all the calculations, we get finite values for all of our components. In conclusion, after the distance of the arc length given, we are at this exact point. Now that we have figured out how to define and apply arc length for vector functions, We can discuss another application of arc length in the next video, which is the curvature or change in curve of a vector function similar to concavity of one-dimensional functions. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.